Hello.
Hello, Lorne.
How are you?
Good, thank you. Do we have all the people present now, actually? It looks like everybody's on time. Is that correct?
We have some of them here. I'm just looking down the list here. We just wait another couple minutes. That would be best. And there's several are on vacation or in the field, which is why we're recording. So thanks for that.
Yep.
And then some it's fairly early, so they're actually here though. Yeah, let's give it another minute or two, and then we'll just I'll watch it recorded. How are you doing?
Good, thanks. This is my first dealings with you guys. I'll save the introduction for when we actually get started, but I'm quite happy to be working with native English speakers for a change. A lot of my work is more in the eastern direction, so I struggle with the language barrier, so this is a new experience for me.
Great. All right. Well, we've used some of your gear up in Yellowknife.
Yeah, you've got the
M24s.
affinities now, I think, in Yellowknife. Sorry, is this the CTBTO array?
Yeah, that's right.
Yeah, I've visited once there.
Oh, okay.
Yeah, because they've got some of those passive GS13s, is that right? Going into so we need a preamplifier to put them into a modern 24-bit digitizer. So that's what I was installing and calibrating up there.
Oh, okay. Oh, great. So,
it's not as cold everywhere.
Really? I don't believe you. I think the whole country is freezing. Whenever I see a picture of Canada, it's snow.
We got a few others here now, so I think we're good to
All right. So, to introduce myself, I am Sean Goosen. I've been with Garau for nearly 25 years. I'm my job title is Field Services Manager. What that it really is just traveling around and helping the customers with problems. And in recent years, not traveling around and doing stuff like this on Zoom. The like. The subject of today's video is to talk about the Fortimus and how to use it. We've allowed ourselves in excess of 3 hours, I think, for this training. I don't think it will take that long. The Fortimus has been designed to be very, very easy to use. Just plug and play, work straight out of the box. So this will be quite an in-depth training if it goes on for more than a couple of hours. Firstly, can I ask, has anyone used, I've heard you've used the affinities in Yellowknife, but has anyone used the Fortimus or Minimus range of grout kit?
We've set up, or some of the team have set up the loaners that came out a couple of weeks ago, and that's about the extent of it.
Okay, great. So I'm hoping, so not everybody has, so I will talk from out of the box. Out of the box, what you get if you haven't seen it on the web page, there's one next to me here, which I'm using for demonstration. It's that. It's even got a screen. That's how easy it is to set up. At the moment, you can see there, this one's actually set up and it's still powered, working on a single cable. It's powered over Ethernet. So if you've got, I highly recommend if you're working with these, to have a hub or a switch that provides power over Ethernet. Just make your life very, very easy because you only got one cable to plug in, and you can set them up in your office. What I would always do when I install any kind of sensor is to configure it in the nice warmth and comfort of my office. So I've got my sample rates, my any kind of LTA, SDA, LTA triggers, or any other bizarre configurations that I want. I set that up in my office before I go out of the field and deploy it. Although I have the ability to change and set things in the field, it's just easier and more comfortable for me to do it. So I would have this power over Ethernet switch, and I would connect all of the units, configure them all, probably quite similar fashion, and then go out and deploy them. Which leads me to the first topic, which is just acquiring the IP address. As with any unit of this nature, you want to communicate with it, you have to find out its IP address. Discovery is a software available on our website, free to use. It's named Discovery because it discovers the units. So it sends out a broadcast on your, please stop me if I'm using words or terminology that you're not familiar with. It broadcasts on the network, and any Graup, Fortis, Fortimus on the local network that's on the same subnet will reply to that broadcast, and Discovery will discover those units because of that. So when you pull up Discovery, you should see your Fortimus, and if you have these set up in your little huddle and your little PoE switch, they'll all appear. So I'm now going to share my screen, which is that of Discovery. First, I'm going to share my entire screen. So here, that's the web interface. My apologies. Here is Discovery. And at a glance, you can see on my subnet, on my local network, there is 3 units connected. And the top one there has appeared as the Fortimus that we're using for the demo today. That's just appeared without me doing anything. If you took the unit out of the box and plugged it into your network, your office network, or even your home network, if it has a DHCP server, then it will just appear. Alternatively, maybe not everybody will understand what I'm talking about, but if your computer is set to DHCP and it does not get access to a DHCP server, it will set its IP address to 169.254.something.something. And it will be on that subnet. That's a default it goes to when the DHCP request has failed. The Fortimus will also do the same thing. So if you were to connect your Fortimus out of the box, it's set to DHCP, directly to your computer via the network cable, then you will still discover it in Discovery because both units will be on the 169.254 network. Then it will appear, and then you can set it to the static IP address that you require. This is the most easy way to do it. Also, getting the IP address, there is a screen on there, and the screen will tell you the IP address that it's got, if it's set to static or DHCP. And then, worst case scenario, for these units, I cannot imagine it being required unless there is an actual fault. There comes supplied with the Fortimus is a serial cable. So you can plug in a, we call it a debug cable, onto the GPS port, set to 115.2 kilobaud, and then you can type in the word help. It will reply with a very, very long list of commands. You can work from there. I think the command is LAN. Well, you type in LAN and it will give you more options. So it's almost menu driven. It's not, it's text-based interface, but more for diagnostics. Using the screen or using Discovery are the first 2 ways to do that. And that's it really. Do you have any questions about the obtaining an IP address from the device? It should be pretty simple. If I don't hear anything, I'll continue onwards. So once you've got the IP address, and it's now displayed on the screen, it's displayed in Discovery, you can go to the IP address in your web browser. There's a little menu option here. This is the basic configuration of the Minimus. So I'll go through each of these tabs: status, elementary, obvious, really, just showing us status. Look for a couple of the critical variables that can change during use. They're highlighted. So the GPS, sometimes that can back a bad signal. So at a very quick glance, we can see green, GPS, GNSS working well. Green, recording, it's okay. Green, I've got enough space on my recording. So it's a very at a glance. But then you can now look at these numbers here. And any errors would be highlighted in red. Anything that needs addressing. Unfortunately, this unit's working perfectly. So nothing's highlighted in red. To go through each of these, so the host name is just to help you identify it in really in Discovery, I think. Sorry, no, the host label is identified in Discovery. The host name cannot be changed. That is for good reason. You can change the ID. You can change the mini-seed naming, fine, but this host name allows you to constantly track it by its serial number, then ID. What type it is, the Fortimus, different products, different types. Serial number, obvious. Firmware version, there is only one firmware version you need to keep track of with the Fortimus. It is that other systems, there may be multiple firmwares involved. This does only has one that you need to check listed here. The IP address, of course, substitute CP at the moment, the seed name. The internal temperature, the internal humidity, input voltage, and if we're getting PoE, what the power coming from the Ethernet is. The point of note, the humidity is an interesting one to have, because if you, there is a little SD card cover. If you were to accidentally leave that off, then you could see in the region of 70–80% humidity there, you would know that that needs addressing. The unit should never really, and I haven't seen them, when they're sealed properly, go much above 60% humidity. The GPS status, it's mostly self-elementary, its location, time, how good a signal it's got. I would expect above 90% for any working unit. Number of satellites. The unit has 2 SD cards. SD cards are not brilliant. They do not record every single bit of data accurately, and occasionally they do miss a bit. This isn't a big deal if you're saving photos to it. You might lose some data in a JPEG. You may lose an entire photo if it's being used very often. So people don't notice, don't really see this with SD cards in the day-to-day use in domestic environments anyway. With seismic data, it can be, anyway, absolutely critical for us to get every single block of data. A single bit missing is quite often unacceptable. So for this reason, we have 2 SD cards. One is used for one is used as a backup. This way, we can be confident that we will record every single bit. The SD cards almost communicate with each other. There's some intelligence software going on inside the Fortimus, so this is almost invisible to the customer, apart from occasional error messages, which are a bit confusing without that knowledge that there are two SD cards. But this means that you can almost blindly remove one of the SD cards and download the data, put it back in, and you can expect no data loss from that procedure. So by default, I think they're 64 gig. Yes, please.
Yeah. So on the map, so I had a discussion with James 2 years ago, actually, when we first discussed the use of this for our project. Many of our stations are on very thin links, and transmission of superfluous or no, I don't mean it quite that sense, but
Yep.
unnecessary data like a map could be problematic and slow down access to the user interfaces. Is there any way that we can suppress the display of the map? Because I think in many cases it's not really necessary.
Yep. I will have to get back to you and check. I think the map is done within the browser, so it's only.
Okay.
I don't think there's much of a data there. However, if I was,
Okay, that's fine.
Yep. But if I was in that world, I've been in that world where bandwidth is absolutely critical. I would not use HTML at all. For state of health monitoring, I would use Discovery. You can see here at a glance, green, green, green. Last time I've seen the unit is just now. If it had become disconnected, that tick would be red, and the last time I had data was there. Its location, there's a number, I think it's voltage, or if I go back over here, that is a list of the things you can have or not have in that main view window. So for your status, state of health monitoring, I would strongly recommend this view here. And I would only use the HTML interface for changing the configuration.
Okay, but even when changing the configuration, which we will need to do,
Yeah.
that's particularly when it's frustrating to sit on an interface that's trickling in bit by bit, as it were. So if you could confirm that either the map data is fetched locally, or not fetched locally, or can be suppressed, I think that would be great.
Yeah, I will confirm that. Okay, so going on to, so I'm just going to go over all the tabs in the configuration. Hopefully it's all self-explanatory. Firstly, with this web interface, there is a login mechanism. This has been created to firstly, to simplify the interface. There's so much you can do with these modern instruments, not just grab others. The only way to make it user-friendly is to hide some of the more complicated options. So we have come up with a device such as a login, which you can use on 2 levels. So you can have nobody can change, this is not secure. I must stress that you should not put this device directly on the internet. It should always be behind some kind of router with a firewall, like any computer. So this login device that we've come up with is just to stop user levels. So you could have this on your private network and everybody can access it, but only somebody with a password could change the configuration. And there's 2 levels to that. So there's a user level and an admin level. I have just logged in as admin. Default username admin, default password admin, and that gives me the ability to change everything I can in the HTML interface. So here now, when I click onto network, I am now viewing all of the options available. The HCP, that is how you receive the units out of the box. If you want to change it to static, you can. Web login, this is the device I was just referring to. So here the defaults, the 2 levels of login are user for basic administrative tasks, which is user, password, user, and then admin. Admin gives you control over everything that's available in the web interface. Seedlink, if you're familiar with Seedlink, then these options will be familiar and they can be changed here. The unit can work on BTP, and that can be enabled there with an error correction. And it mentions an NTP server there, and it does not work. I do not recommend using with an NTP timing source. It only retrieves, I believe at the moment, we've been battling with this, NTP gets the time at boot up, but then the clock will drift thereafter. Of the absolute best and recommended, which I believe you are using, is the GNSS receivers to give you the most accurate timestamp most reliably. Registry. Now, the registry service is a option we provide such that you can to negotiate over the problem of DHCP addresses changing. I'm not going to talk about this today. That is a more to do with the network infrastructure. I believe you're having a meeting about tomorrow. Is that right, James?
Next week is the software. Next
week, the software. But generally speaking, the registry, so you have a registry server on your network, and if you have its IP address entered here, then the Fortimus will communicate with the registry, your discovery software can communicate with the registry, and then they can find each other. Because without knowing IP addresses, how can you find a unit on the larger network? And it helps with you with creating a tunnel. Here is a tunnel, again, much more on the network side of things. I won't go into other than to explain generally what a tunnel is, and that is a way of getting from one network to another, and in this case using PPP. GDI, auto connection. GDI is Group data interconnect formats, very super low latency transmission protocol. And here with the ability to push the data from the Fortimus to a known IP address 4 times for 4 different locations. QSCD is it's a new one for me. I will skip over QSCD. I believe that's another form of tunnel, a grout simplified tunnel, such that you just enter the IP address and this code. But I will check on that. My apologies. Wi-Fi, I hope again is self-explanatory. These units, depending on the model you ordered, can have Wi-Fi. This one does, which is why it's appeared here. Just a general note, the firmware is.
Could you talk a little bit about this tunneling that you've got, just so we know what it is? I don't know that we would use it, but
sure. So tunneling comes in a variety of formats, for ways of doing, ways of achieving a tunnel. You need to have the tunnel created both ends. So a recent project I worked on I had 3G modems, and in England, it's difficult to get a SIM card with a static IP address. I think it's almost impossible now. So you have a problem with connecting to the unit. So you can discover it, you can find the IP address, you can set the IP address. Sorry, you can't set the IP address of the 3G modem. So using the registry, you can type in and you can create a registry server. There is a publicly available one created by Grout. You give it a unique ID for your network, and then you enter the same parameters in Discovery, and the units will connect, and all of the data and all the communications will travel through that registry server. So it makes the maintenance of the network much easier. With the tunnels, I am not the best person to speak to with detail on how Group's implemented the tunnel here.
Okay, so I think it sounds like something we would probably not use, because we set up VPN tunnels between our cell modem or router or whatever, and our data center, and everything else lives inside that. So I just wanted to be clear whether this was applicable to our situation. I guess not.
If you've already got tunnels set up, then you wouldn't put a tunnel through a tunnel.
Yeah, exactly.
Yeah. And yes, so I'm very much aware of SSH tunnels, but Group's implementation here I have not used before, to be honest. But I will bring that up with a colleague who is talking to you next week.
That'd be great. And do you know if that registry service, if that like what the latency impacts would be of that?
The latency impact on the registry service, yes, there is a small impact, and that would be very much depending on your network. I would not use the Group supplied one, because our current registry server, our publicly available one, is in London on an Amazon server thing, but they're quite simple to set up, and we can very easily assist you setting one up, but that may not be applicable to your network. Certainly with early warning, I wouldn't. Again, and the latency introduced will be that of the extra distance traveled across the network and how fast that network is.
Yeah. Okay.
So, but this is the network configuration, and that's very much related to what you're talking about next week. So please ignore low latency mode balanced. There is no low latency. Sorry, my mistake. In your instances, you would like minimum latency. It has very little effect on the power consumption. It does increase the power consumption by a small amount just because the processor is running faster. Auto reboot on error, I think that's self-explanatory. The auto refresh is the HTML page on the status. It automatically refreshes. Hostname is for identification within Discovery. Station code, network code, site name, and location code are all the mini-seeds IDs. If you use mini-seed or you're changing this configuration, you'll be very familiar with what these are. Bluetooth I will talk about later. You can set a pin, possibly recommended if it's near a school or where people might be playing with Bluetooth, but they would have to coincidentally download the app. You can always just, if you're not using Bluetooth and you don't foresee using it, then you can switch it off here. Filter quality. I have never had cause to turn it to low and fast. I have to get back to you on that one. Sorry, I know that is potentially very relevant to NRCan. That implementation, so I was not expecting that button to be there, to be honest, because the only two filter quality parameters there could be is causal or acausal filtering on the decimation, on the digitizer side of things, and I wouldn't expect that to be in a Fortimus. So we'll get back to you on what exactly the implications are with that setting. Deploy mode is only applicable to OBS. By the way, quite often you can hover over one of these descriptions and it will give you a more detailed description. There we can see this is only applied to a OBS system. This is not an OBS. Sensor installation parameters. So here, sorry, applied rotation. So not particularly applicable to this unit, but certainly a good use cases for boreholes. So you cannot change the orientation of a seismometer 100 meters underground. So it's quite often common to rotate. And here we can rotate just along the horizontal plane to correct for the offset to either true north or magnetic north. That's not to be confused with this setting here, which this applied rotation along zero will apply it to the actual data that's transmitted from the sensor. Here, this dip and azimuth, that is only what will be reported in the dataless RASP files, and depth as well. Has no bearing on the actual data that's being sent, just on the dataless. So the Fortimus units have an auto-centering function, and you would see that operating here. Also, you can center them manually. When you first switch the unit on, you may see this reporting busy, as it's just scanning its internals, work out exactly what it is. If we thought we were talking, if we're using a Fortimus and it says something different here, that would be a problem. Here you can change the gain of the instrument to what you can see there, and that changes the gain in the feedback loop. That is not just a digital gain, that is a gain of substance. So if you put it down to 0.5, then you will actually get a step up in improvement, so improved self-noise. Of course, the problem therein lies is it will clip too early, but that is not a digital gain. It is an actual gain applied to the feedback to give you real-world performance change. I won't use the word improvement because we're reducing the dynamic range when we increase the gain. This option here is a bit of a bizarre one. We can stop the feedback to the instrument. You would not want to do this ever unless you were doing some sort of debug. If you were trying to ascertain if there is a fault with the instrument, then grub support might ask you to switch it into open loop feedback, which would enable us to understand that there is an actual problem with the mechanical parts of the unit. Sensor mass, self-explanatory. Calibration, so the digitizer is capable of generating a triangle wave, square wave, or white noise. It's important to know that regardless of temperature, regardless of time elapsed, the calibration will not change in these units. It's a closed loop feedback system. The calibration won't change. But some people like to check. You can do it with this. A very nice thing about accelerometers is they're very, very easy to calibrate. You can just put them on their side. They will measure 1G. You can put them upside down. The vertical will measure 2G. So that's my recommendation, is to use that method. If you're testing the unit in any way, if you're not sure if your calibration values are correct, the absolute rock solid way of knowing that your accelerometer is, and the data you are getting is accurate, is to put the unit on the side. You should measure 1G if your calibration values are correct, if your sensor is working. And the display can be switched off, its brightness altered, and flip and touch sensitive. It's a touch sensitive display. I remember people at Graup talking about having a touch sensitive display, and I was one of the cynical people on the side of it. I thought, that's stupid. I work in the field. It is never sunny and dry. It is wet, cold, and miserable in the field. And a touchscreen display is not going to work. However, I've tried to break it. As soon as I got my hands on one, I put it in the sink, I put it in the freezer. I was most concerned that it would register false touches. So it would be installed perfectly well, and then there would be raindrops dropping on the display, and it would be registering them as touches. It hasn't done any of that. It's just worked. So I was proved wrong, and it's a Perspex cover. It doesn't break very easily. I trust it enough, but you can switch it off, and that's available there. And it might get particularly cold in Canada, and your raindrops might be particularly worse than English raindrops and register as touches or something. So you can switch it off. Triggering. So this will depend on how familiar you are with triggering. It's possibly very relevant to what you're doing. There is a lot to configure here. Do you have an exact trigger? Are you going to use, first of all, can I ask the Fortimus to do any remote triggering? Has that been considered? Regardless, sorry?
It's been considered, but I wouldn't. It's not the.
Okay, so I will gloss over this implementation because it's not complicated, but there's just a lot of different ways of going about it. We need to set up, and so let me go over. I'll talk about the trigger after I've talked about the data stream. That will make more sense. The data stream, very self-explanatory. So there is only one sensor. So at the moment, we're only displaying the streams that are switched on. It makes for an easier view. You can look at all of them, and you can see there is a lot. And this, in part, is trying to please all of the people all the time. There is, for example, a stream that tells you the GPS is working okay. I don't think it's necessary to know that the GPS is working 5 times a second, but that stream exists. Humidity streamed in real time 10 times a second if you want. Your voltage input. So if you have the bandwidth, then it could be quite nice to stream some of these channels. For example, your voltage, if you're running on solar panels and your voltage starts to drop at night, at 5 in the morning, you're getting down to 11.8 volts, then this could work in a nice way for you to get an early warning that you need to improve your power solution. Temperature, a good installation an ideal installation should have no temperature fluctuations. That's not going to be the case, so you could track that, and however you could help you diagnose problems. If you're getting too much drift on the sensor and you're not using a high-pass filter, then you could check the temperature fluctuations. The rotation is the pitch calculated from the magnetometer that's inside the unit. Same with the, so there is a magnetometer and there is also a MEMS sensor. So further up here, there is a MEMS sensor. The MEMS sensor, it sounds like, superficially, it sounds like a very nice solution. So you can set your Fortimus up to have a high gain of 0.5 G, but if there's an event, then you're guaranteed to capture the event with the MEMS sensor. However, MEMS are not very good. In general, they are not particularly linear, and in this case, it is not, I think it's not calibrated. Certainly not calibrated with any level of accuracy. And when I say it's not linear, I have not myself measured the non-linearity either of the in frequency or out the amplitude domain. So this is not really what this device is for. It's not an iPhone. It's an accelerometer. Magnetometer. These devices are the same as what is in your mobile phone. So the magnetometer, if you're familiar with that in your phone, from time to time it needs calibrating. So it could be useful in some instances, but to calibrate a magnetometer, if you're familiar with it with your phone, you have to move it around in a figure of 8 and expose it to every axis. Not particularly convenient for something that's bolted to the concrete, as I expect you'll be doing. There are use cases for all of these tools here, but I'm just trying to limit expectations from when you see a MEMS sensor or a magnetometer. So for example, if somebody was deploying a Fortimus 10 times in different locations with the power remaining on, because they're doing a very, very quick noise survey of a basement, then the MEMS sensor and the magnetometer could be useful in that situation. So, low latency seismic channels. So they sound magical. They just sound like seismic channels at low latency. You may choose to use these, but they have a causal filter, not the better acausal. Acausal is a better filter, but when you're talking about low latency and data as absolutely quickly as you can get it, then causal is the way to go. Anybody who's familiar with these two types of filtering will know. That's not the subject of this training, the difference between causal and acausal. And the auxiliary channels, which I mentioned before, humidity, rotation, GPS, and if you're interested in any particular one, you can hover over it and a description appears. They're also well documented in the manual. Going back up to so this is the main three channels, the Z, N, and E, 24-bit, high resolution, well time-stamped, low noise, good quality data. There's six displayed here, 2 taps. If you're familiar with seismic digitizers, this is quite common. There is only 2 taps, and they can be configured independently, both for what's being streamed and for what's being recorded. So you could transmit low sample rate data because of bandwidth requirements, but you could record high samples. So you could transmit 2 samples per second, 1 sample per second, more as a state of health, and then on any event, and then you could record at up to 4,000 samples per second. And then when there is an event of interest, you could download only that section of data, for example. And also, before I move into the data record, there is this enable transform, which we will do for the main 3 channels, just so that we have more options appearing. Data stream. And then under data record, exactly the same window again, but can be configured completely separately. Normally when I'm working with these units, and they are somewhat set up for what I expect, then I will only have the enabled channels displayed just for ease of use. And there you can see on this particular unit, it's recording quite a lot. It's 64 gig, 200 hertz, it's over a year, not a problem. So whenever you've changed a configuration, changed a setting, that requires a reboot, not all changes to settings do require a reboot, then that message there will appear, reboot required. So we can reboot the unit, and it will take always less than, so it will take less than a minute for the web page to come back up. Other things require some initialization, but the web page will appear quite quickly. Is there any questions at this point? Okay, that's positive. Like I said, it's quite easy. I think it's quite simple unit to use. The manual is well documented. Once you've got that IP address, you have some demo units, you can play with the interface. So units backup, status has changed. We just spoke about data stream, data record, and I'll go on to tree. 1 second. So before I go on to triggering, I have under this option here, under the data transform, I've enabled it, rebooted, and now I'm presented with these options. Again, documented in the manual, please play with it. But you can see here we can change the channel to do something quite different. I won't go through all of it. Something of note that's more relevant to this training than other things would probably be the earthquake early warning, so I can switch this on. Okay, so now I've enabled the cat parameters, EEW cat parameters. I can now go on to the triggering and grabs implementation of that. And it may be something you could consider in your network going forward on the side, separate, such that you can see the results, especially the speed of the results of the early warning. And so you could potentially configure this separately and monitor it. So to talk about CAP alerts in general, I've forgotten the acronym. James, can you find out the acronym for what CAP stands for, CAP alerts?
Alert protocol.
CAP alert protocol.
Common alert protocol.
Common alert. That's a meaningless, meaningless acronym. Common alert protocol. So it's, I think its origins of its formatting come from Google, and it's created just as a, the CAP alert is a single IP packet. So if you're familiar with computer networking at all, you transmit an email, you send an email that gets broken up into thousands upon thousands of packets. It gets transmitted across the network and then is reassembled back at the other end. This is perfectly efficient, fine, great. The internet works brilliantly. However, not for speed. So a CAP alert is a single IP packet which contains very little data, but just enough data. So the ID, the location, the magnitude, and why it's being sent. So what value was exceeded, sorry, what threshold was exceeded by what value. This, because it's a single IP packet, it is the absolute fastest way to transmit over the network. Cannot go any faster. There is the possibility that you could lose the packet, but it's a good way to do early warning, especially when you have multiple stations. Right, you need multiple stations. So within that, the settings we're looking at here are, you can configure it to have, start game, go on to local tap triggers. Okay, so here, we can set a trigger. This needs another reboot. And you would probably want, from the higher sample rate data, the triplets. We'll also put all these at 0 as well. And then we do another reboot. I'm just glossing over the triggering. It's something you can play with if you're interested. Also, caution, I don't want to take up too much of your time. If there's any questions at any point, please interrupt me. So under trigger, we can select the standard STA-LTA. Here you can change the parameters of that STA-LTA trigger, its window size, etc., etc. And I hope there's a filter on there. Yeah. There's a filter to remove high pass if you want. Certainly, if you were using a level trigger, you must do a high pass. And then I believe here, yeah, here is where you configure the trigger. So you set it, sorry, this is where you configure the trigger. You set it up here, and it sends a message to here, the triggers configuration. So that's and you give it a score. And where do you send it? CAP receiver, and that is an IP address which you can enter here through the port. And that will work. Again, it's something you could consider setting up on a number of units just to see the speed and how really fast it is. It's certainly if you are using an STA-LTA or a level triggering to determine if there has been something measured at a single station, then that is the fastest way to do it at the digitizer source. And you could use that. You could run the STA-LTA trigger on causal data and then retrieve your high sample rate acausal data from the unit after the alert, after the primary event detection, because you can easily script the downloading of data from these units. And that's documented in the manual. You could use Python, for example, use obspy, which is what I do, to download the data automatically upon receiving an alert. But that is not what you're doing in this case. In this case, you're getting real-time data across your network, and again, the subject of next week's discussion. So that is data record, and then we have storage. There I can see the two SD cards. Everything's green, primary concern. If there was a problem with one of the SD cards, or if one had not been, like for example, if the primary one had not been inserted properly, we would get red, orange, or green, red or orange messages here. Red is a error. Orange will be a warning. For example, something will go orange if the storage is approaching a full state of being full. So if you had 80% written to the SD card, they would pop up as orange to give you an alert. But that would also be the case in Discovery. Here, this this picture of an SD card would turn orange when you're approaching full, and red when there's a problem. You can see there's a minimus on this network. Don't know where it is, but it's got an error because it's filled its SD card. There is only 2.4% left on the SD card space. The raw data that's recorded to the SD card looks like this. So by all means, you can download this data through the HTML interface, click on every unit, download a particular channel you're interested in. Each one of those files is fills itself up to the size of 128 megabytes, then it creates a new one. It's not, I accept it's not a particularly tidy way of doing it. This is the only way it can be done because we need it to be hot swappable. We need people to remove and insert these SD cards. We need them to be reliably written in a naming format that is unchanging. Otherwise, the problems occur. So that's fine for us. If we want to download the data, then we can do it by the chat from in time windows, so that we can select the channel we want, the from and to time, and then download that. There are tools, graphical tools through Discovery to do this as well. Also, you can write a script that will download it over FTP via the via FTP or HTTP, FTP. That is documented in the manual. You can use wget to pull off the data, and I would certainly recommend that if you're doing it in multiple units, because of course downloading through there, if you're doing a month of data, quite time consuming. You can grab or supply these units with SD cards. You can purchase your own SD cards as backup, but I can't remember. Please ask us for our recommendation. There is a certain standard of SD card that we recommend, an industrial standard grade 10 or some such. Please email us. Please email us for recommendation. And that's the web interface. I've glossed over the details. It is a web interface, pretty easy to navigate. Should not be able to break the unit. If you do break a unit by pressing any of these buttons, thank you. Please let us know. You're helping us debug, find the problems with the unit. It's been a while now. This is pretty much unchanged. It's proving very reliable. I don't think there is a button or operation you can do on the web interface that would damage the unit in any way. So you are welcome to play with, and on our and there is methods to reset to factory defaults. So you can reset all settings and go back to the start if it gets too messed up. You're messing around. So you've installed the unit, you've configured the unit. How do you check that it's working? If you're installing, let's use a use case. If I was installing in a basement in Canada, then I'm indoors, and I would pull out my laptop and I would connect to the unit through Discovery. It should just appear. Then I can right-click Live View and view the GDI data. Just saw the GPS was red there. I hadn't plugged it back in properly. So this is a live view. I'm on the same network. There's no latency issues because I've just installed the unit. So I'm just going to view the higher sample rate data. So I know I've got the power on, the screen's displayed, the LED's flashing. The LED is flashing green, which actually gives me the information that effectively those three lights are green. So the little LED green flashing means that it's transmitting data, it's got a good GPS lock, and it's writing data to the SD card. Those three conditions have to be met for the green LED to be flashing. So I already have some confidence. But because I'm not outdoors, it's not raining, I'm in a basement, I can power up my laptop in relative safety, and then I can, with this Discovery, I've right-clicked on the unit, Live View, I can tap the unit, and I see that it responds immediately after tapping. So that's fine, but how well is the unit really working? Have I installed it well? Is it bolted to the concrete well? Is there a hole underneath what I've just bolted it to? How good are the results I'm going to get? So with Discovery, you can grab some data. It's touchscreen as well. And let's grab a bit more than that. All 3 channels, in fact. And there we can have a PSD. And this is sitting on a table next to me. I can barely see the lines from the sensor. Not surprising. This would be a big concern if I just bolted this to concrete for something to be out of shot there. Here we can see the line. These should be much lower down. So if I've bolted this to concrete and it looks like this, I've obviously done something wrong. Exactly where these lines appear depend on many factors, and if you're not familiar, you will get quite familiar quite quickly if you install a few of these units on what to expect. Our example at the moment is a basement. So if there was a washing machine operating upstairs, I would probably see that appear as some sort of resonance around 50-40 hertz. But that's okay because there's a washing machine nearby. It's what the ground is doing. So the Fortimus, the accelerometer, isn't going to measure anything. That's not a fault. So what you're looking for here is, depending on the location, the amplitude of these signals, any spikes, and also a good check is both horizontals should be fairly similar, and the vertical should not differ too much from the horizontals, but it should be a little different, is what you would commonly expect. And that's all you can do with an accelerometer to check that it is working okay. Of course, the timing, but with only one unit, you have to trust the state of health from the digitizer. It's green, it says 100%, it says it's locked, you have to trust that. You cannot measure accurately the timestamp, the data timestamp. Any questions?
What is C0 on the channel list?
That's calibration channel. So I would not normally have that enabled. So that is a 24-bit channel that measures the input with a digital calibration. With any calibration, measure what goes in, measure what comes out, and you've calibrated it. So that's there. Those are the other channels that are enabled, those environmental ones. Now, whilst I'm on installation, I'll go on to the Bluetooth. So if you go into the Play Store and type in Guvu, G-U-V-U, or you can type in Graup, and Guvu will appear. It's on the Play Store and on the App Store. And this is another way to talk with the device. Now, I would use Guvu if my laptop's run out of power or it's raining too much for me to get my laptop out. But it will always be my preference to use Discovery such that I can do that PSD. However, I can, with using Guvu, I can see the real-time traces. So I can see when I tap the unit that it responds. I can see the state of health of the GPS and that is recording. So it is a compromise to use the Guvu Bluetooth app, but at the same time can be very convenient if you are installing many units and pressed for time, or you're in conditions such that it's not easy to use a laptop. Now I will go on to calibration. So, because when we did that PSD, we were already checking the calibration was correct. Discovery receives the calibration information automatically from Fortimus and scales accordingly. You can see that this is actually, this scale here is in meters per second. When I highlight the unit, these units are in meters per second squared because it's received calibration information from the Fortimus. The actual data that's transmitted by any seismic instrumentation I know of when it's digital is in counts. So you need calibration information alongside that. So if anyone's not familiar, there is data, the raw counts from the sensor, and the data list. Data list is in a number of different formats. The Fortimus has .xml, it has data lists, and it has .resp files. Before I continue, is there a particular one that you are familiar with or you do use often? No, I will talk about them as generally as I can. The data list is not human readable, it's binary format, so you need software to decode that. I won't do that today in front of you. Number of packages can read the data list, like OBSPy, that's what Discovery reads. Then there is a .xml, which is in the .xml format. And then there is a RESP file, which is ASCII text. So the latter two, the XML and the RESP files, are human readable, so you can see those and check that they are okay. So there, the data list is available for download, so you can click on that and download the file. It is also available if you type it in here on the web interface. And if we type in station.xml, here we can see the XML file as it stands. To see, it's not as easy to read as the not so easy to read REST files. So there is to note that the data streamed and the recorded have their own separate information because their seed IDs are different always. And that's the REST file, which is many people will be familiar with. This is human readable, and we can see the I've obviously clicked on something not right. That was the calibration channel, which does not have any poles and zeros. Oops. Go somewhere else. That's because transforms have been applied. There we are. That's a good RESP file for a standard channel. The really good news is you don't have to do anything with these modern instruments, and because the Fortimus has an integrated digitizer and analog sensor, when you receive this from the factory, it already has this information. This was not the case 5 years ago for most manufacturers, I believe, and it was quite the administrative task to maintain your calibration information for each of your stations. Here it is now recorded locally on the station by the digitizer, and you don't have to do anything. It's all here. And it's available to be used by whatever software. this means you can now, if you choose to, focus the shift away from storing your calibration on a server, your calibration information on a server, or anything like that, especially for your real-time processing. You can rely on the digitizer. So whenever you need calibration information, you can query the digitizer. Equally, you can you can retrieve the calibration information from the digitizer and then store it on your server. But you do not have to enter any of these numbers in manually, which wasn't the case not so long ago. So that's very pleasant. You can enter this in manually. If you did have another a different Grout product where you only bought the digitizer, then you would have to tell the digitizer what sensor is connected, such that the REST file, the dataless file, XML files will be accurate. And that can be done through here, under calibration, edit balls and zeros. Now, here is a window where you can set the information. But as you can see, any unit, an integrated unit where the digitizer and analog sensor are the same, this has already been set in the factory by Grout, which is wondrous if you've ever had the experience of maintaining RESP files. Now, so with Discovery, when you have your network connected, I do recommend using Discovery as your state of health monitoring. You can also go to a unit and find it on a map. This really does give you a general overview of your network and alerts you quickly to any outages just by this traffic light, green, red, yellow system. Does anybody have any questions?
One question, but maybe you're getting to it, is or maybe I missed it, is like configuration files for download and upload. So
Thank you. Yes, I had that on my list of talking points, which is on that. Yes, so that's done through Discovery. So there, as you can see, especially with the triggering, for example, there's a lot of potential parameters that you could set, and you could use those as your defaults if they're significantly different from Grout's. So you could, under system configuration, select the unit, and download configuration. Here we can download to desktop. And here I have a configuration file, which I can then upload to the other units, such as same unit again. Select the units that I wish to upload that configuration to and upload the configuration. That's simple, but very useful. I didn't mention the data calendar view. So there is a number of tools in Discovery that are quite new. And here we can see the data on this unit that's been recorded to the SD card. It only got switched on at 11:15 this morning for the first time. And whilst it was powered, it was recorded, and for each stream where the data is available on the SD card. Quite convenient. Yeah, way to see see how much data you have recorded and if there are any gaps on that SD card. Here you could download the data as well. So I could select.
Does it do the intercomparison between the two cards?
That's done inside the Fortimus.
Okay.
So the Fortimus is the firmware is such that it knows that what is on the two SD cards should be identical, and it will work to maintain it. So there you can see how we can choose segments of data and download via that interface as well as see the availability.
Going back to when you did the after you did the waveform view and the PSD, if you're doing an install, is there a way to capture that in the field, that PSD, and go to a screen capture? But I mean,
yeah, I probably would. So you can certainly just save the data, which is probably the better way to do that. I would save that chunk of data, but yeah, that's probably the way I go about doing that. You could also save the picture as a PNG. Sorry, as an image. Okay, is there any questions?
I have some questions about the GPS antenna. I don't know when you do the installation. How can you secure the GPS antenna on poles or roof?
So you need a pole.
Yeah, I have one unit right now. I just have a quick look of the antenna. There's no mounting brackets and everything.
Okay, so no, this it's fair enough point. There is no mounting brackets, but there is this groove here has been intended such that you could use the don't recall the name of them, very strong or indestructible metal cable ties to wrap it to a pole, or you could just use a U-bolt, commonly available, but the actual size of U-bolt would depend on the pipe that you're bolting it to. This could go onto a number of different sized pipes, just like. And you can also stick the set, if you've got a narrow pole, you may be able to stick the entire cable through the center of the pole and put the GPS directly on top.
Okay, another question. I think sometimes we have to install this unit in the basement, and I'm just curious if the cable, what if the cable is not long enough? Is there any way for us to make an extension cable for the for GPS?
If you're familiar with LEMO connectors, that it's pin, of course it's extending, so it's pin to pin. It's RS422 signals. The power consumption is very low, so we are confident you could extend it up to 50 meters, no problem. You can also purchase extending cables from Garant.
Okay.
That's great. That was my question too. Thanks, Mingzhou. And the extension cables, can we get them in different lengths, like prefab from you?
Yeah, we make them in either 5 or 10 meter sections. So if it needs to go any longer, then we would supply multiple extender cables.
Okay, yeah, because I think we got the 10 meter, and there's the situation that Mingzhou was talking about that we know now that we're getting down to actually planning the stations where we need longer than 10 meters. So it's good to know we can go up to 50, and we will have to get a number of extension cables of some length.
I have a question. Is there an option to have the GPS engine close to the sensor and have an antenna extend all the way to whatever length you want?
Sorry, could you ask that again?
Is there an option for you guys to have the GPS engine down near the sensor and have the antenna with coax extends to whatever length you want? In that way, then you have no limit of running cable.
No, we don't have that ability. We've very much integrated our GPS. The cable you have is not coax. If you've held one, you will have seen. Yes, no, you can't do that.
Another question. I saw the power cable that you guys supply. It's only, power and return. Is there a ground that we can connect to?
Yeah. There should be our unit is 0 volts is ground.
No, I'm saying is there a chassis ground that we can connect to? Because the cable doesn't have, even the pinout doesn't have, ground, earth ground.
Yeah, our ground is our chassis ground is our 0 volts. They are all the same.
So, I see. Okay. So the return ground is basically your earth ground to connect it to the device.
Yeah. Yes.
Okay.
Sorry, one more question. Yeah. So I didn't see the low power disconnect option on the Fortimus. So in case the power reach extremely low, let's say, I don't know, 7 volt or something, is it going to shut down? What's the where's the configuration? Like we can do.
Okay, it's non-configurable. It's the hardware. It's exact cutoff. I can't recall. This is something James will let you know. The LVD, low voltage disconnect set on the Fortimus, is in the hardware. You cannot change it in the software. That exact voltage number, I don't know off the top of my head. It should be around 11 point something volts to save your batteries.
Okay.
So if the power, or if our LVD, because we have our own power manager, and it shut down early, can it cause corruption if you pull a plug suddenly to the Fortimus?
No, there is no. In fact, there is no way to switch off the unit nicely. There is no off button. So the only way to switch it off is to remove the power.
No, I'm saying does that cause data corruption? Because you're recording data and then you store it probably in RAM or something, and then if it's power out suddenly, you lost that data and it caused data corruption on certain part of
Okay, so I don't like to use the word data corruption because that sounds like there was data lost. Yes, there will be a when there's no power, there won't be any data, but that's really with a few seconds either side. There, you will only lose data from when the unit is switched off.
I think Andy is actually asking if there's any way we can corrupt the data, like in the actual sense that we are going to corrupt it by doing something to the power and turning it off before it wants to turn off.
Yeah, we've worked hard on that not being the case. There is no, because our files are 128 megabyte that are recorded on the actual SD card. So if there was anything corrupted, then you would lose 128 megabytes of data, which of one channel, which you really don't want. So there is no. I've not witnessed any corruption.
Okay.
Did
that answer?
Sorry.
Oh, I was just going to ask Andy if that answered his question.
Well, I guess we will lose, like I said, the worst case we will lose 128 megabyte of data, while recording.
Yeah, I've not witnessed that occurring myself. We have got now thousands of these kind of units in the field. So there is, so we do have problems from time to time, even if it's only 0.1%. That's still dozens of units in the field that the issues that we've seen have not been anything to do with corrupt data. There's been a lightning strike, but we have been able to fix the units by just a complete factory reset. So yes, we can, in this case, we can use the word corruption, but that's more on the level of the firmware, where only a factory reset and reloading the actual code inside the unit has recovered the system. But then we've lost all data because it's had quite a serious jolt.
So another question about, like you said, that you have to do a factory reset remotely. Can you recover remotely to the device if you do a factory reset? Or
depending on the fault. Depending on the faults, if you still have internet, if you can still communicate with the device, 9 times out of 10, 99 times out of 100, we can recover it. If not, there is a fault condition, which we have seen maybe on a dozen occasions. It isn't quite fair to talk about this, but you are going to have quite a high quantity, so I'm sure this will occur at some point, where we have a serial debug cable which you can connect to the units, and that's.
But that's only if you're locally. Remotely,
yeah,
we will talk about 1,000 kilometers away.
Yeah, well, in that case, if you've, I'm saying 99 times out of 100, if you've got Ethernet connection and you communicate some way through the Ethernet to the device, then we have commands to recover. But if there is no connection, then if there's no Ethernet connection at all, then the only thing we can do is connect via serial, which we have a cable supplied for. But yes, that does require being local. Unless you were to configure, unless your modem or your device that's supplying network also has the ability to give you a serial console and connect up that cable as well. But that's, I think, an unnecessary step.
So I have a question about the SD card. Which brand SD card Grok will recommend to use?
I don't know off the top of my head. We have a recommendation. People have asked us before, and we have recommended the industrial high-grade quality, the best one that's commercially available. Off the top of my head, I don't remember what that's.
We bought some Delkin industrial SD card for Fortimus and the 10SMA. So we have those, and then I'm testing them, and they seem to work.
Yep.
The limit is 64 gig, though. I'm just reading the documentation. It says the limit is 64 gig, and not both cards are hot swappable. One is an internal one that can't be removed, and the other one is the hot swappable one.
Correct.
And the maximum is 64 gig.
I would not use anything other than 64 gig because the one inside the unit you would not want to remove. This is the backup one that is there for as a backup to assist the primary one in not losing any data. So that doesn't need to be touched ever. The only reason you will touch the external one is to retrieve the data very quickly, and in which case you want to put a replacement one in there to replace the one you taken out, and that is where you would be buying and using your own ones.
Yeah, the only instructions it gives in the user guide is GurLab only recommends using the supplied industrial grade micro SD cards. So is that something that has to be purchased from GurLab, or is it something? I
will have to default to sales. They're not exactly special units. You'll see when you take them out, they're not manufactured or in any way dealt with by Grout. They are off-the-shelf commercial units. That may be an old piece of advice where we were covering our bases and just not wanting people to put any old SD card in there and then blame us for gaps and whatnot.
I can follow up after this training session with a link to the SD cards we use.
Have you ever run into a position you kind of added the configuration file, for example, the IP address, and I accidentally forgot to put a dot in there, and then I upload the configuration file? What will happen?
Okay, so I'd like to say I've never made a mistake, but that's if you've entered the wrong IP address, what can happen there? So worst case scenario is you'd enter in an IP address that is on a different subnet. Then you will no longer be able to communicate with it unless you can find its IP address. And here you are stuck with a situation where you have a unit with an unknown IP address, an unknown static IP address. And in that scenario, we're fortunate it's got a screen and we can look at the screen.
Well, I mean, what if it's the IP address I enter is illegal?
Sorry, if the IP address is illegal?
Yeah, it's not even valid.
Oh, I don't think.
If I put 4 zeros.
I have confidence that my software team have written a good. We'll try it now. It should not accept and. So we will try and set bad DNS. We'll have 2 dots. You have an invalid IP address. It won't let you. The HTML interface won't let you.
I mean, if you ask the XML, the configuration file, do you think it was same thing? It won't even take it? Like, they just say upload failed or something?
So if you were trying to use wget to retrieve the file, or
so normally I guess for testing purpose I want to do download the configuration file, and I want to change some of the parameters at the configuration file, for example IP address and subnet and everything, and then I want to upload to a different unit, and I make a mistake. Like what will happen? I don't want to screw up the unit, but I just want to know if that's a trick to do it.
Sorry, no, the configuration will not touch the IP address.
Oh, okay.
For that very reason, the configuration file, yeah.
So just ignore it, then take the rest of the settings.
Yeah.
So, and also, okay, from this page, you have registry, and then there's a registry address and group ID.
Yes.
We normally have firewall in case we want to use registry, like what port number we need to open for them to communicate, or I don't need to do anything.
It might go over our tunnels, and it would just be like a LAN address that the station router would know how to get to.
Okay, right, okay.
I don't know which port off the top of my head. Sorry, I can find out. But yeah, if you've got generic internet access, then outbound, then it will work.
So are we going to use SeedLink? This question is for Aidan. Are we going to use SeedLink for the data streaming?
I thought we would use the, what is it, GDI protocol that goes to that acquisition software that will be running. In the same way that for the nanometrics devices, we're going to use Apollo server instead of like a generic SeedLink acquisition. We're going to use the manufacturer's protocol to, it's going to have less latency.
Okay.
We need to talk to Charles on that, because he was, Henry and Charles were talking with them, so they might actually be going SeedLink.
Lauren, can you turn up your volume? I can't hear you at all.
Oh, no? Okay, yeah, I was saying you had discussions with Charles, and there was a possibility of going with SeedLink.
And also when I deploy the station, what if I didn't if I didn't secure the sensor nicely? Let's, for example, it's loose on the ground. Is there any way to tell from the calibration? Well, not the PSD file. Like, do you have an example?
I think you can do a plot like he just shown earlier. Do a plot, PSC's plot on instant data on discovery.
Yeah. So you'll
PSD plot.
You'll see this with the PSD, and I described how to do that. Interpreting the PSD as a sensor being poorly mounted to good concrete instead of a sensor being well mounted to bad concrete, if that makes sense, is a little bit. I can try and think of examples that I come up with. Possibly resonance is one manifestation of a poorly mounted sensor because it's wobbling, but equally that resonance could be from a machine 5 meters away behind a wall, so you don't know it's there. It's not a precise field of, really, if you just bolt the sensor down and not let it wobble is surely the easiest way to do this, because interpreting the data and telling the difference between poorly coupled sensor and poor ground isn't necessarily so easy.
Right. Sometimes when we install the sensor in the basement, we don't have the idea, like if we actually doing the orientation correctly. And maybe we can figure it out later. However, it's difficult to visit to the site to physically change it. So I think you have a setting to correct the orientation by degrees. So which direction is going, like the rotations? Like, so if I put 10 degree, like what's that represent? Is it like to the left or to the right?
So it's clockwise. So if you enter in 10 degrees here, you are rotating. As you're looking from above the sensor down, you are rotating the sensor plus 10 clockwise degrees. So if you were to measure a deviation of 10 degrees plus 10 degrees from true north, then you would enter -10 in that window there.
Okay.
Mingzhu, I don't think that's how we should be doing things. We've not done that in the past. When we have angular corrections to be made to the data, that's in the past. We do that through the data center. It goes into the database and is applied that way. So if we start doing in two different ways, one through the instrument and then another one through the processing database, we're going to end up in a real mess.
Oh, okay, yeah.
I have a question.
But I mean, we need to record it, right? I mean, if you know you've got a problem, then we need to know that. The other comment I have on that issue is we have now bought these inertial gyroscopes to solve exactly this problem. I don't know what the status of those is. I think they were delivered, but
yeah, I think one's delivered to PGC and one's here. So one's in Ottawa and one at Sydney. Yeah.
Okay.
I have a question regarding I guess the NTP server. can you put the URL address instead of a static IP for the server? I think it's under,
I don't know, to be honest. We could only. That's a question, a follow-up question. James, make a note. NTP. Can you type in? You mean PTP? Oh, sorry, no, the NTP.
Yeah, yeah. Did you have a static IP there? Is there? Can you put like NTP.pool or .org, something like that?
To be honest, I don't know. I have not done that before.
Because the server, I mean, for the NTP server, the server can be everywhere, right? I mean, it doesn't have to be, if this down and you screw, right? So if you have a standard URL address, then it just, kind of grab from whatever server is available.
Yes.
Apparently the NTP only does it on boot up, though, you said, and then it's
yes,
drifts.
Yeah. So the NTP is only used when the when it synchronizes clock the first time on boot up. NTP is not a recommended solution for timing on this device.
Well, it seemed like I said we may have to use it quite a bit because most of ours is kind of under the building, and its GPS is kind of hard to get to run to. I mean, to connect to.
PTP in those places.
Yeah, under that case, you would use PTP.
So one of the students did a lot of work on testing the PTP. Obviously, we didn't have a Geralt device at that time, and we found it to be quite successful, even over multiple subnetworks.
Did we test it under, like, over the tunnel? Like, we have a PTP server, at our server, and it goes through the tunnel and all the way to the station.
The Geralt tunnel, I don't know the answer to. I can't confidently answer that. If you have your own tunnel, then it should be fine.
I don't think we're going to use the Geralt tunnels. I think we.
No, I'm saying that it's like, have we tested through our tunnel? Like, did you test it like locally, or you?
Yes.
Okay.
Yeah, there's a report on that. I can send it. Well, I'll send it to the whole list, or maybe Lauren should.
Yeah, I sent it out not too long ago, so we should have it.
Yeah, I just worried that if we have like one PTP and then if that goes down and that you have no backup, I was just wondering how can you get that backup?
Is that more than one PTP? What you're asking?
Yeah.
There's a multicast for, I don't know if that's
another question.
Yeah.
So I saw I think I saw something like a power over Ethernet. Like, is this how we power up the Fortimus?
Fortimus, you have two power options. You have DC voltage in, or you can use PoE.
Okay, so the PoE you're using.
Yeah, what's the voltage range for the Fortimus over power over Ethernet? Does it take 12 volt?
No.
Can it power up to 12 volt?
Not with the power over Ethernet. Power over Ethernet is quite a fussy standard. Our implementation, again, I have to follow up with an email of the exact description of our implementation of it. Again, it's on our website. It is the 48 volts, and it has to be implemented correctly. So the correct standard is documented on our website, and it's 48 volts.
Okay.
So I believe that the cables were built to supply 12 volts. We had you guys build custom cables. I've not actually seen one, but certainly the specification required that you take 12 volts. So I would imagine it goes to the power connector. So we would not be using PoE.
Yeah. Thereby, just but be aware of the PoE option. Perhaps not for installation, but for if you're doing a huddle test in your office, or if you're configuring multiple of them, then it may be easy because you can just use PoE injector switch and multiple standard Ethernet cables.
Just a quick question. I noticed that when you were changing a setting in any setting in the Fortimus webpage, that it was almost like you waited for the page to refresh before you changed the next setting. Is that something that we have to do, or?
Yes. Sorry, okay. I'm used to this. There is each time, I'm just trying to find so here I make a change, and then that was quite quick. Make a change again. Yeah. So that speed, and I don't know what it depends on, to be honest. It does vary a little bit, but then it's changed. So there is a small time delay when you enter something into a field.
So just don't do things quick. Wait for the page to refresh. Okay.
Yes, you can't. It refreshes fairly quickly most of the time, but once you've entered in something, there it's refreshed. So, yeah.
Okay, good to know. Also, I noticed when you changed I think it was the sample rate or I think you enabled a transform or you changed the tool, or I can't remember what you did, but you hit the reboot button and then it rebooted. Can you explain that a little bit more?
Okay, so changing some of the settings requires a reboot. Changing some other settings does not require a reboot.
Okay.
If you do require a reboot, that message appears here.
Good to know.
In red. And there is another nuance when you're working with, and I think this is the only section it applies to, this and the triggering. So when you enable these transforms, just to be able to see that list, you first have to enable the transform, which requires a reboot. Frustrating, but at the moment, that's the way this interface works. Does not know the available. Yes, go on.
Is that reboot button that's just to the right?
So there's a reboot button there. There's a reboot button there, I think, under triggering. So under all of these tabs, there is a reboot button such that, yeah.
Can you go over the bubble leveling, the internal, I guess, the digital bubble leveling? Because one of my colleagues mentioned that it's not as responsive. You had to kind of, once you kind of move the feet and you adjust the feet, and then you had to wait a while for it to move.
Yes. And I will talk from a practical experience in the real world. When I'm installing one of these in my toolkit, I have a bubble level and I put it on top of the device.
Okay.
The digital displays are nice and fancy and whatever, but no, just an analog bubble in your pocket without out sticking out.
So I guess in the future design, should the Fortimus may have a bubble, a mechanical, physical bubble built into it?
There's very little space. You put the display in there.
So, and also there's a mass centering. Where can I check the mass center?
So on the status page, there is the output, and because it's an accelerometer, then it's not like a seismometer with velocity, where your mass position is your acceleration output, giving you the actual offset. So the counts, the data coming out is how centered the instrument is.
Okay, so how often you need to do the mass centering? I'm not expecting you to do it very often, but
I would never expect to center an instrument of this type.
Okay.
After installation.
So when you plug in the DC power supply, and if it's 24 volt, basically the voltage will appear on both power over Ethernet and the input voltage, even though the PoE is not enabled.
If you're looking at my window here, then the input voltage, yeah, I admit this isn't very clear. If you are not running on PoE, the input voltage will show the voltage you are running on, and the PoE will show nothing. It shows 0. If you're running on PoE, then you will get what you see here. Yeah, that needs to be refined.
Okay, so right now you have it on PoE or not?
Yes, I have it on PoE.
Which means it will work on 24 volt and 48 volt.
1 minute, please. No, it's running on 54 volts at the moment. I appreciate in the power over Ethernet it says 23 volts. There is a bug with this unit. I will talk with my colleagues about that and find out. Another item to follow up with, James. Why is this unit? I'm giving it 54 volts at the moment over its PoE.
Oh, that's the maximum you can have, I guess.
Yep.
And the SD card, I believe it's a ring buffer SD card, so which means I don't need to replace the card unless I want to grab the data.
Yes, so once the SD card is full, you are losing the oldest data.
Okay.
One question about SD card. Is there a way, I guess, if the card is full, you have to kind of physically, I guess you have to log in remotely and kind of delete certain file or download certain file or remove file off the SD card for space you can do, right? Or is there a way to, cycle the SD card, an option to cycle the SD card?
So by default, it's in a circular buffer, so it deletes the oldest and writes the latest data.
Okay. So is there an option to unclick it so it doesn't cycle?
Right once. There is not an option at the moment. It's on our R&D to-do list, is to have a button there to enable you to have a write once. We have not had any customers ask for that yet, but we're expecting someone to.
Yeah, because for example, if there's a big earthquake and it causes an outage to our communication, and we don't want to lose certain data on the SD card, right? So we probably have an option to not to cycle the data.
Sure, but in a real world situation, 64 gig.
Yeah, well,
it's gonna be a year or two.
Yeah, I understand, but like I said, some site is we can't get to.
Yeah.
At least 3 months. Yeah.
Yeah.
Is there an option to flag an event then? I know with the GNSS receivers that we use, some of them can do that where it basically secures the data. That portion of data won't overwrite, even if you're in a ring buffer.
So you could, I haven't done this before, but I think you could record on trigger.
So yeah, I want you guys to keep going. I have to cut over to another meeting. So
yeah, I don't have an answer to that one right now. Yes, I'm sure there could be a way of doing that. Not quite sure how at the moment. It's not something that's come up again. 64 gig takes a long time to fill that up.
And also, in case we have to do a firmware upgrade, what's the minimum bandwidth that it would require?
I wouldn't describe it as a minimum bandwidth. If it's it will struggle and error correct, and it will work or not work. So if the bandwidth is low, it will work fine. If there is an outage, after a certain amount of time, it will stop.
Okay.
Is there a way that we can upload the firmware to the device via SSH or rsync, some kind of option? Then maybe we can split up the file like kind of into small pieces and then upload one part at a time. So it doesn't cost because we have a Libra station that's running a very low bandwidth. We're talking about like 64K, So I'm just wondering if there's an option that we can upload file remotely at low bandwidth station.
So when you do a firmware update, you are uploading a file to the Fortimus. If you were to, and this is managed through discovery protocols, there is no way to upgrade the firmware without discovery.
Oh, I see. Okay.
Okay. To finish off, my email, James, can you type it into the chat? My email is.
Sorry, I have one more.
Yes?
I have one more question. Sorry. So I don't know if you already addressed this. I'm actually attending 2 meetings at the same time, but and I've got 2 ears, but I don't have 2 brains. So what we would like to do is stream with minimal latency with the fast filter, the data from the instruments to our data center for early warning processing. So that's one piece. In addition, we'd like to set up a second stream of data applying the high quality filter. I can never remember which is causal and acausal, which without thinking it through. So at a higher sample rate, probably 200 samples per second, and record it locally. And then if there is an interesting event, we would manually or actually preferably via some kind of script, fetch back that chunk of data belonging to that interesting event with the high quality filter and the higher sample rate. Can that be done? And can you provide us with the appropriate parameters to do that?
Yes, that can be done. That's very typical, common, good way of using a seismometer. Yes, so you'll have causal. What do you know? What sample rate you'd have your fast data?
Probably 200.
Okay, so you've got 200 causal being transmitted in real time.
No, sorry, 100 causal in real time, 200 acausal for later fetching back.
Okay, so you wouldn't be receiving anything apart from the causal 100 samples per second.
That's right.
Okay. Then you would record locally on the digitizer acausal 200 samples per second.
Correct.
And then you would have some way, preferably automatically, scripting, downloading any data in the acausal 200 samples per second.
Yeah.
Anything more?
Not that I can think of right now. If you have suggestions, we'd certainly welcome them.
Yeah, I probably would, just as an interest in the eyes of, I think many of us are scientists and love to experiment, do research or what have you. And on the side, you could set up one of these grout cap alerts just to see its speed, because it doesn't cost you anything. There is no cost related to having this single IP alert, and you can see if that's faster than your current solution you're working with causal being transmitted in real time at 100 samples per second. But no, I don't really have any recommendations, and that's a very easy thing to set up. And I will forward on to anybody interested a script that will automatically will take a couple of dates and automatically download from a list of IP addresses.
Great, that'd be a great help. So there is a second session of this training intended more for our data center folks. I don't know that I'm going to have time to attend that one, but the whole question of scripting and automatization of processes. We have a lot of sensors in this network, and manual management is going to be prohibitively expensive in terms of staff. So any suggestions on how to do stuff would be appreciated.
Yep.
The other point that we're going to need to refine, because I don't think we quite understand it yet, is the question of recording latencies in a way that we understand what the latency means, because we need to be able to monitoring latency through the early warning system network is a critical parameter. So I'm hoping that the people who attend the next session bring that up, and you can elaborate on what exactly those latencies that you quote mean are, and how to access those and slice them and dice them through our state of health monitoring systems.
Yeah.
And we fully expect that the first cut on this will probably need some work, but this is an area that's quite important.
Yeah. So today I've been specifically talking or trying to talk about the hardware installation side of things.
Understood. Yeah.
And problems you might encounter, how to diagnose problems, check that the sensor is deployed and working correctly. As I said at the start, this is very much the very, very easy. It's very much discovery, touchscreen, easy to use. HTML interface can't really be more simple. So hopefully you won't run into any problems with that. And I'm certainly available. So my email address, James put into the chat, is goosen@garoup.com. And also there is a email address, support@garoup.com. That is not manned by any one individual. So if you have a query about GPSs, you write to support and it will go to Garoup's expert at GPSs. You have a question about accelerometers, the question will go to the next available person who knows stuff about accelerometers. That's the reason for that address. But absolutely, you can email me personally anytime. Okay.
Okay. Thank you very much, everyone. As we mentioned during the training session, I'll follow up with an email addressing some of the questions that we couldn't answer during the session, and also a link to the recording of this session for you to distribute to whoever can make it today.
Thank you very much for showing us that today. That was very helpful.
Yes, thank you. Yeah, look forward to working with you some more.
Thank you, everyone.